So I am Tracy Reagan. I am the CEO of Deploy Hub. I'm also on the board of the CD Foundation. I kind of took up the task of putting together a CD Foundation online meetup. We were slow to get started, but then COVID hit and everything just went to being online. So these meetups have become pretty interesting. We've had some really, really interesting speakers. Including today, Steve Terrana. I met Steve talking about, I'm not sure how we got in the conversation, but I found him around the conversation of templating for Jenkins, and he did a demo for me, and I was really excited. I think the JTE is one of the more interesting projects, personally, around Jenkins, because as you will see today, the ability to template and the way that the JTE does templating is super, super simple. And anything that's simple is brilliant. And so I'm pretty excited about the Jenkins templating engine. Stephen, are you still there? We may have lost him. Hopefully he will sign back in. Stephen Terrana works at Booz Allen, and he is he works with tons of different customers in building out their pipelines. And this was one of the reasons why he created the JTE, because he had the need to create multiple types of pipelines kind of on the fly. Now, while everybody doesn't have that requirement right now, I think what we're going to find is as we move into microservices, we'll have more pipelines. We'll be managing more pieces, and teams want to use different tools. And again, that's why the JTE is super interesting. Next month, I usually announce what we're going to do next month at these meetings. Next month is the CDCon. So CDCon is, I should know the dates, it's at the end of June. So please register for CDCon. We will not be doing a regular CD Online meetup in June. We will do that in July, and I'm working on a Spinnaker presentation. So on that note, I am going to pass it off to Stephen, and he is going to take us through a journey on how to template Jenkins.
Awesome. Thanks, Tracy. Can you can still hear me okay? I dropped for a second there.
Yeah,
okay.
You're good. You're all good.
Thank you. All right. So before I dive into a terminal, I don't have any slides for you today. I thought that might be a nice refreshing break from slides all day. I'm going to give some context of like what was the problem we were trying to solve. So Tracy mentioned microservices and how teams that have even 5, 10, 50 microservices and are trying to automate their software delivery processes, you'll find yourself violating the dry principle all over the place, right? You need to define what is that pipeline going to look like for each microservice. There's some stuff you can do around, reusable code in Jenkins, but there wasn't really a way to define in one place what is the pipeline that's going to happen for all these different repositories, and then how can I plug and play with that pipeline if I'm using different tools across different services. So if I've got some front end microservices, maybe some Spring Boot apps, maybe I've got some stuff written in Python, how can I write one pipeline that's flexible enough to work with all of those? So the Jenkins templating engine makes that possible. And I hope by the end of the next 45 minutes, we explain how. So diving right into code here, and feel free to interrupt me at any point if something is too small or too big, and I can fix that. So right off the bat, there's some infrastructure automation that I'm going to show you, so that there's no call it no magic, right? Nothing here is automagically happening. So there's a just file. If you haven't heard of Just, it's a pretty cool project. It's sort of like a make file without all the baggage. Sorry, make. So it's a task runner. So it takes away a lot of the complexity of running some commands. So I've got a Just file that's going to automate some stuff for us today. I have a Jenkins directory that has a Docker file. So I'm just going to pull Jenkins LTS. I'm going to turn off the startup wizard. I'm going to install some plugins. And then I'm going to use JCask, Jenkins configuration as code, to automate a Jenkins configuration so that we can hit the ground running with the demo. Plugins.txt, if you're familiar with Jenkins, just all the plugins I want to install, and then JCask. So we'll get into exactly what this means in a little bit, but the gist of it is that we're going to develop some libraries in the Jenkins templating engine that contribute steps to the pipeline. Jenkins needs to know where to get those libraries from. So in this demo, these libraries are going to live locally. This Docker file in this container that we're going to launch has a volume mount that lets us reference this library. So that's the gist of the automation here. So I can run just launch Jenkins. It's going to build this image if it needs to. It's going to launch it. And in a second here, we will have Jenkins up and running on localhost 8080. So that's going to take a second to come up. While it does, I'm going to run a command in the background throughout this. So we've got a local directory. I don't want to have to constantly commit files to get them to show up. So I'm going to run this just watch command. And all that's going to do is watch this directory for changes to Groovy files. And when I change a Groovy file, it's instantly going to commit it. So that's not important for JTE, just explaining some of what's going on here. There's a file watcher that's going to commit all our file changes so that as I create libraries, they're automatically accessible inside Jenkins. And that's all we need out of this just file. So I'm already running just watch. It kicked off onto a demo branch. I'm going to open up a new terminal here and we can get started. So Jenkins should be up and running here. I can go create my first pipeline job. If we want to go to create job. So there's a lot of different ways to use JTE, but the simplest for demo purposes is to create a regular old pipeline job. So I can click create. Now, if you're used to using Jenkins, there's some screens you're used to where you can define what your pipeline is going to do. When you install the Jenkins templating engine, it adds a new option where I can provide two things. I can provide a default pipeline template. So just to make things real simple to start, we'll just print out hello world and we'll do it inside a node block too. So echo hi. So I wouldn't typically recommend you write advanced pipeline code inside your template, but just for building that mental model of how JTE works, this template is just a Jenkins file. There's some magic that happens before the template runs to inject things into the pipeline environment, but it's important to understand that there's nothing special about this template. I can run regular old pipeline code and it's going to work as expected. So the rest of this demo will be turning that template into an actual template. But I think sometimes with JTE, there's a misconception that it's a different DSL than the typical Jenkins Groovy that you might be used to writing. So let's make this a template. Let's say my software delivery process has a build step. I can create a build method, or I can call a build method. And now down here in pipeline configurations, there's a lot of things that you can configure. We're going to start off with libraries. So in JTE, we call this a step. So the template is invoking a build step. Steps come from libraries. So let's say I have a team that's using Maven. I can create a Maven library. And right now that doesn't exist. So if I go and build this, assuming I correctly wiped the slate from when I was making sure this is going to work, the pipeline's going to fail, right? And it's going to fail because library Maven not found. So let's go create a Maven library. I can come over to our code terminal and just another helper. I have a recipe called create, and all it does is make some directories for me. So if I say just create Maven, it's going to spin up this Maven directory. And then within the Maven directory, there are 3 directories that comprise a library. There's resources. So that means any file that you want to be able to fetch the file contents of during your pipeline execution. So this could be like configuration YAML files or shell scripts or Python scripts or whatever you want to fetch. You can put in the resources directory. The source directory is for class files. If for some reason you have some object-oriented type code that you want to write, the bulk of where we're going to live today is in this steps directory. So I can create a new file. In our template, we said that we wanted to invoke a build step, and we wanted to get it from the Maven library, right? So to create that, inside the steps directory, I can make a build.groovy file. So the step name that's going to be contributed is the base name of the file in the steps directory. So I can create a call method. I can say println building from Maven. And just some Groovy-ism. The fact that it's a call method is actually just Groovy syntactic sugar. So when you say build, open close parentheses in Groovy, that's actually shorthand for build.call. So if you've used like Jenkins shared libraries and you were wondering like, why do I have to make this call method? The reason you make the call method is because it's syntactic sugar for being able to invoke it by the short name. So I save this file. If you remember, we've got a file watcher that committed that change for me already. So if we go back to Jenkins now, the Maven library exists. So I can build it. And what's going to happen is if you look at the build logs, and I can make this a little bit bigger, JTE tells you everything that it does. So here are the pipeline configurations that we found. In our example, all we did was set a Maven library, and it doesn't have a configuration right now. And we'll show in a bit how you can pass parameters to these libraries. At the bottom, we can see that JTE is going to run a step from the Maven library called build, and we're going to invoke the call method inside that step. And we'll see that it says building from Maven. So just to demonstrate that that's just syntactic sugar, if we change this to build.call and we rerun it, the exact same thing is going to happen. So now let's get into like, cool, you made a framework that lets me put methods in here, but how does that actually help me scale things? So what would happen if we had another team that instead of using Maven was actually using Gradle, right? So in practice, these jobs would be pointed at like GitHub organization projects or multi-branch folders where you're actually defining the pipeline configuration for an entire repository or an entire GitHub organization or Bitbucket project or what have you. So in this example, we can change the pipeline behavior without actually changing the pipeline template. So a team that's using Maven and a team that's using Gradle and a team that's using NPM could all be using an inherited pipeline template that says build, and then we can swap this out. So we can create a Gradle library instead. And in practice, these pipeline configurations can come from like the application source code repository. So let's create that Gradle library. Get rid of this comment here. And we can go create a build.groovy. It's going to be the same code, except we're going to say we're building from Gradle. Now, the important part here is that your template is defining like an API spec almost for what your pipeline is going to do. And you get to define whatever you want that to be. This is really a framework for pipeline development that you can share across teams. So the template's defining that I expect there to be a step contributed by a library that contributes a build step. So now both the Maven and the Gradle libraries have this build step. So depending upon, I'll save this and run it. Depending upon which libraries I load, we can get different pipeline functionality out of the same exact pipeline template, right? So I'm gonna foot stomp that for like another 15 seconds. Like back in the day, like 2 years ago, when I was working with teams that had 50 or 60 microservices, or they had a whole bunch of different, applications that they were building pipelines for, that used to mean if I wanted to change the pipeline across all those teams, I had to go open 50 or 60 pull requests, right? Or we had to orchestrate that change across all these different teams. With the Jenkins templating engine, that pipeline template gets pulled out of individual source code repositories, gets defined in a central location in tool agnostic terms, and then these libraries provide a means for plugging and playing with the interface that you've created through your template. So let's talk about, and I know we've got another 40 minutes here, but if there's any questions, feel free to put them in the chat, and Tracy, you can feel free to interrupt me if there's anything to talk about. But these libraries are only as useful as they are reusable, right? So let's imagine we wanted to pass data from the pipeline configuration to those steps. So let's just take, for example, that we wanted to pass a message to the Gradle library, right? This configuration file is it's a Groovy-based DSL configuration language. So it's just a bunch of nested blocks. When you load the library, you can pass in whatever parameters you want to define. There's sandboxing in place and whatnot, so don't go trying to read like the etc password file, but you can define the typical variables you'd be used to around strings, arrays, booleans, what have you. So we can define this parameter, we can click save. And now from the Gradle library, if I want to consume that, we can say println, the message was, and JTE does a lot of framework syntactic sugar to make things as easy as possible for you. And one of those things that we do is we inject a config variable into your steps. So this config variable gives you access to that library configuration. So if we want to print out the message from the user, we can say config.message. The JTE 201 class will talk about different strategies for validating pipeline input from users. Libraries can have library configuration files, but the gist is that through those libraries, instead of defining method parameters, you define library configurations, and then they get added to this config variable. So if we go back to Jenkins and we run this job just to prove that it's going to work as expected, we can see that the message that got printed out was what we defined in the pipeline configuration. So, along the way, I'm going to be using a lot of print statements to show features, but I'm going to try to map all these features back to real world use cases where that's important. So one example that comes to mind is, let's say I have a SonarQube library, and some teams want to fail the build on quality gate, and other teams don't. Now, as a DevOps purist, you should fail the build if there's bad code quality. But in the real world, sometimes when teams are just getting started, or they've got less strict standards, that might be a setting that you want to control. That's the type of thing that all your teams can reuse this SonarQube library, but you can tailor the execution of the steps based upon these pipeline configurations. JTE has hierarchical pipeline configurations. So you can define a pipeline configuration that applies to the entire Jenkins instance, and then you can define one that applies to a specific application. So there's a lot of strategies for controlling which pieces of this pipeline template are inherited and governed, and which pieces of this pipeline are going to be configurable by individual application teams. Typically, for example, I wouldn't want individual teams to be able to override like container image scanning settings, right? If I want to fail the build, if there are highs, that's the type of thing I would consolidate into a governed pipeline configuration. And I would let the teams tell me what build tool are you using, for example. But you don't get to change, the container image scan policies that you're going to inherit. So far we covered steps, right? The gist here is that you can create whatever interface you want to in this pipeline template. And then you can create as many libraries as you want to that implement this interface, right? And these libraries can take library configurations to tailor their behavior for each application. So just a quick aside on why you wouldn't want to do this. So if you pass method parameters, and this takes some getting used to, which is why I'm calling it out, right? Traditionally, when you want to pass data to a method, you make it a method parameter. But the challenge in JTE is that if this build step takes a string parameter, right? Like let's say we did string message. Now every other build parameter or every other build method would have to implement the same interface, right? Because let's say I swap out that template from Maven and I'm still passing it here as a template parameter. Now I'm not accepting a string parameter and things are going to fail. So the reason that library configurations are passed through the pipeline configuration file are to make sure that we get, that plug and play nature from our steps. It doesn't matter what data each library wants to take in, and it's totally decoupled from, the template. I can plug and play with whatever libraries I want to for a build step. I'm gonna pause there just to give people an opportunity to type any questions that they might have. But while we do that, the next feature I want to talk about is application environments. So sometimes the one exception to the rule I just said is that sometimes it makes sense to create a method parameter for application environments. So JTE has what are called primitives. So steps are an example of a template primitive. We're going to create a new library that contributes a deploy to step. And we're going to see how this dev variable gets into the template. So inside the pipeline configuration, you can create a block called application environments. And this is an opportunity for you to define any environmental context that you want to be able to pass around to deployment steps or steps that are going to do integration testing or what have you. So let's create a library called Ansible. So let's assume, hypothetically that we wanted to do a deployment through Ansible. And let's assume that Ansible library was going to contribute a step called deploy to, which takes in the environment to deploy to. That was a lot of twos. So inside this application environments block, we create a dev environment, and we're going to create an array of IP addresses. In practice, I would not recommend that you construct your library this way, but it makes for a good demo here. So we can say that for a dev environment, the IP addresses are 1111 and 2222 respectively. And we'll create a test environment too that is similar. So now I can say deploy to dev and deploy to test. This dev variable comes from the key that you created, right? So you specified, here are some application environments. One of them is called dev. And now you can define whatever data you want. In the real world, this might be, I've got different Kubernetes clusters for my deployments. I've got, a different tag that I should look up on EC2 instances to do deployments to, auto scaling groups, whatever is unique about your application environments that you need to be able to tell the pipeline about. This gives you a construct to be able to capture that information and then pass it in your template in a way that still makes the template easy to read. So if we run this now, it's going to fail. We haven't made our Ansible library yet. So we can come over, say just create Ansible. And in the steps directory again, we said deploy to. Some more groovyism. In the template, we said deploy to dev. Deploy to dev is functionally equivalent to deploy to dev. So I'm a fan of using those those syntactic sugar features of Groovy to make the templates really easy to read, but staying in touch with our no magic, this is what's actually happening behind the scenes. So we can implement a call method that takes an app environment. And for our example, we can just say that appenv.IP addresses, right, which is the configuration that we put on the application environment, .each. So we're going to iterate over the IPs, and we're just going to say println deploying to IP. So this is just going to demonstrate that we're able to take in this context and then use it. So when we run the pipeline, we'll see some deployment statements for deploying to, let's put some stages in here, deploy to appenv. And these application environments have a short name variable automatically that you can reference. So we'll say that we're going to deploy to dev and to test just to make it easier to see. We'll save this. So I don't want to go too quick here. So we created a stage for just visualization purposes to see when we're deploying to which environment. We're going to read in the parameter, which is the application environment, and then access the IP addresses field that we configured. And then we're just going to print it out to mock what that would look like. So if we come back and we run the pipeline, we can see that we've got a stage here, deploy to dev. It deployed to the IP addresses we configured for the dev environment. And then we deployed to test, and it used the test application environments. Some other features.
So hang on before you go there, Steve.
Sure.
You have some questions that relate to what you just were showing.
Sure.
One question is, where would you put node labels needed for running pipelines? And I think you referred to that somewhat, but there's an example that says Linux versus Windows, etc.
That's a great question. So the Jenkins templating engine is just a fancy way to aggregate pipeline code. You can define node labels wherever you want to, which isn't super helpful. So let me try to give a couple like design patterns that I've seen in the wild. But the technical answer is kind of wherever you want to. So if you wanted to, inside your Ansible library, say that the node label, it was going to be, I don't know, Linux. Then in your Ansible library, you could come in here. This is going to fail because I don't have a node called Linux. But you could come in here and you could say that my node block takes a label of config.node label. Let's make this code a little bit easier to read. So up at the top, I can parse some configuration. So I can say that the string for the node label is going to be equal to the config.node label. Just to show how like some error checking could happen here. I could also say, if this node label is not defined, fall back to executing this closure, define the node label. So we'll come into here, give some space to the code, and we can say that the node is going to take the node label variable that we defined above, and you pass it in, right? So in this case, I expect this to fail because I don't actually have a node label called Linux, but we can show what would happen if I didn't define this. So let's take this out, rerun the job. See, and we had a failure because you needed to define that node label. So the options here are, you could define it for the entire pipeline. I think a lot of people that are coming from declarative, and JTE does have some declarative support. So if you say pipeline, agent any stages, I'm not as familiar with declarative syntax, but let's see if I can do this real quick. Steps, build. So let's make this a little bit bigger too. So you can also do it the declarative way, which is where you have these agent blocks and maybe you don't define nodes inside your steps. So we could create a stage called build that consumes the build step from Gradle. This is a live demo, so this might not pass on the first go here. Missing. Oh, so that's a fun one actually. So because build is actually a Jenkins pipeline step, the way that the step resolution works is that it's trying to call the Jenkins step instead of the JTE step. So a way we can get around that is to put it in a script block. And if we save that and we build it, so here was the build step running through declarative syntax where you can define agents the way that you're used to. Let's also create a unit test step just because I want to show that as long as there's no step name collision, unit test isn't a Jenkins step that you can execute, whereas build is. We can save that. We can, inside our Gradle library, real quick for demo purposes, create that unit test.groovy file, void call, println unit test from Gradle. Save this and build it. So I would expect that this works as expected inside the steps block. And again, the only reason we had to put the build step inside a script block was because it overrides. And there's actually a warning that will show you that JTE is overriding a Jenkins step with the name build. But your original question was around node labeling. So the two options was option one, define it inside your library step and pass library configuration options for what you want the node labels to be. Option two, you can use declarative syntax and not handle node logic inside your steps at all and let the declarative framework account for that. And then option three is in some cases, you'll have a helper, like a utility library that defines some common logic. So for the libraries that I maintain, there's a function called inside image, and it takes a string that's the image name, and it does some stuff like it'll do a Docker image name, and this is very abbreviated version of the code. But if we wanted to create this method signature, we can create a helper function called inside image. We could say it takes a closure. And this would be inside a utility library. So let me comment that. Utility library. And a utility library is not a special thing. It would be like libraries utility. But then inside your consuming steps, you can use that helper function, right? So if I wanted to make a build.groovy file and delegate node label assignments or Kubernetes pod templates to this utility library, I would just say inside image, I want to run inside the Maven image, and here's my closure to execute, which is, I don't know, sh maven-v or maven clean package. So because I'm rambling a little bit, but because JTE is just a framework for how to aggregate pipeline code, it's really up to you how you want to handle the node labels. There's sort of a couple different patterns that we just went through.
Okay, here's another one for you. This is about DSL and pipeline configurations. It says, is pipeline configurations with Jenkins always DSL, or does it have a wrapper or plugin so you can do it in YAML or JSON?
So right now it's always Groovy, but it would definitely be possible to do it inside YAML or JSON. The reason that the tricky part is going to be around the aggregation. So you can have more than one pipeline configuration file. I mentioned that a little bit earlier. You can define one common to the whole Jenkins instance. So let's talk through a quick example, and we'll use this as a playground inside here. If I organizationally, we'll put some comments, org pipeline configuration. Let's say I wanted to add I don't know, Anchor as a common library everyone has to use. But I want other teams, like an application team, to be able to add additional libraries. The way you would define that with this DSL is you would say at merge. And at merge is saying we're going to let teams add libraries to this libraries block. There's also at override if you want them to be able to replace it. So this functionality of how you're going to determine what blocks and keys of the pipeline configuration can be modified would be a little tricky in YAML. Definitely not impossible. You could just do an array of YAML paths or something. But as of right now, it's always Groovy. I don't know if I made that more complicated than it had to be. Right now, the answer is always Groovy. The answer is in the future, there could be ways to do it with other configuration languages.
Now you have two other questions that kind of seem similar. One says, what happens if you deploy _to prod, but the prod does not exist in the application dash environments? And the other one is, how does JTE understand deploy _to dev as when dev values reside is under application _ environments namespace?
Sure. Let's take them one at a time. So we had an Ansible. Let's see if I can Control Z my way back. So we had an Ansible library. So let's just do it. Deploy to prod. So what I expect to happen is that it's going to say you tried to reference a variable that doesn't exist, right? There's going to be a missing property exception that gets thrown. At the very start of this, we said that templates are just Jenkins files. So what's actually happening is that there's an object called application environment. Well, there's a class called application environment, and there's an instantiation of that class called dev that gets put into the pipeline execution. So deploy to dev, it was able to resolve dev because there's actually an object that is called dev that gets created when JTE is initializing or parsing your pipeline configuration. So if we say deploy to prod, because it's just Groovy and just a Jenkins file, it's going to throw that no such property exception. I think I covered both of them. The way that the second one was, how does JTE know about this dev variable? And the answer again is that there's a variable called dev that gets injected to your runtime. Right. So, sorry, go ahead.
So I think you answered both those. Awesome. Another one is, do you recommend adding a library with no op steps and having a more sophisticated full pipeline for all projects, or having multiple templates instead?
It's a great question. There's actually a feature for that. So let's say my test was, I want to do unit, I want to do build, I want to do unit test, I want to do, I don't know, container image scan. We haven't done anything that implements container image scan yet. And at the end, we'll do deploy to dev and deploy to test. So you can flesh out this entire pipeline. And then there's another block inside your pipeline configuration called template methods. So in our case, the methods that might be run from the template would be build, unit test, container image scan, and that's not right, and deploy to. So what this block does, because you, as the pipeline author, determine this interface, JTE has no way to know whether this step was supposed to exist or whether it's part of your template. So what the template methods block does is it gives you a way to tell JTE, these are the steps that might be loaded. And now if it's not loaded, it becomes a no op step, right? So you could build this and it's going to print out, oh, I need to define the node label. So let's switch our tests back over to Maven because I modified the Gradle library. We'll do Maven, get rid of this configuration, try again.
Which was a really good example of how the JTE works, right? Switching between was really easy.
Oh, I did it in the Ansible library. Let's just go fix that real quick. So I'll delete this unit test step in the Ansible library. I did that here. But yeah, that was a great demo.
Really good use case.
So let's try that again. Let me see if the file watcher is still running. All right, that looks good. Save this file. Let's look here. Let's look here. Let's look. All right, that looks fine. Oh, because I did it at the top of the file. That's why. So in Ansible, at the top of deploy to, this is where the exception is done. So we'll get rid of it there. For the fun of live demos off script. So now when we run this, we'll see that for the unit test step, which wasn't implemented, and for the container image scan, which wasn't implemented, a no-op step replaced it with a message that says this was not implemented. There should be a feature, there's not today, but this is a great first PR for anyone that's interested, to make to enforce whether or not these should be loaded, right? It should definitely be possible to say enforced equals true and then fail the build if no library was loaded to implement this. But as of right now, the way that it works is you define a list, and then if these steps aren't provided by a library, they will become no-op steps in their placement to avoid the method, like the method missing exception that would be thrown, right? So if I, just to demo what would happen if we didn't do this, if I got rid of this block and I tried to execute the unit test step, it's going to fail, right? There's no unit test defined. So we get the typical Jenkins, like, I don't know what you're asking me for. I hope that makes sense.
You have one more question out there. I'm not quite sure that what they're asking. It says, can I get how you make Jenkins up in seconds?
Yeah. Are you asking about the infrastructure as code stuff? So inside Jenkins, inside this Jenkins directory, I have a Docker file that defines my custom Jenkins image that installs plugins and installs JCask. And then I started off the demo by running just launch Jenkins. You could have just run these commands yourself. So it cleans up if there's an old container, and then it runs a new one. I'm mounting my little demo directory to the container. And then Jenkins is looking for this directory as a library source. So there's a couple, I guess, automation tricks going on to make the live demo seamless, but it's JCask and it's Docker, a custom Docker image, and it's this just file that's doing some automation here for the demo.
And I put
there's actually.
I'm sorry, but I put the link into the where you referenced just. You better make sure it's the right place. It's the place that I would have used it from. And the base repository that I'm using to do this it's on my my GitHub profile. So feel free to take a screenshot, go to this link, and why don't you put that in the chat?
Sure.
Yeah, that will help.
Let me see. So I see Q&A here.
Yeah, it's kind of weird to find your chat. Yeah.
Yeah, I got it. So yeah, go start the repo. It gives me little doses of dopamine. So that'll have all the Docker file and the stuff for that. Any other questions before I show off one last feature here?
You're good.
All right. So this last one I like to show because it's a personal favorite. What if I wanted to do something like Slack notifications? So let's simplify this pipeline to just the build step again. Now, the whole point of JTE is that I can decouple technologies and I can plug and play. But there are those edge cases around like notifications or metric sending. I don't want to put my Slack notification logic inside all my libraries, right? That would be now enforcing that Slack exists. So JTE has a way to address this. And we'll simplify this down to what's needed. So save here. So same as before, we have to create a Slack library. Under steps, I can create a, I don't know, notifications.groovy file. So let's say I wanted to deploy, or I wanted to send a notification before every other step that takes place. JTE has, they're called lifecycle annotations or hooks. So I can say at before step, and now I can put that on whatever method I want to. I can say println running before, and the framework provides another auto-wired variable called hook context. So I can say I'm running before the libraries hook context.step. So now, just by loading this library, without having to change my template at all, just because I loaded Slack and Slack has a annotated method that registers the method for execution before each step. So I can come in and we see that Slack kicks off and it says running before Maven's build. And there's a whole bunch of these fun annotations. I can say after step, and I can say running after. Should have just copied this. And there's some more. Let's define these in order that they're going to happen. So there's an init one. If you have some code you want to run at the beginning of the pipeline, there's an cleanup for if you want to run things at the end. And there's even a notify one that is a combination of other annotations. So void notify, println notify. So let's save this. And if we want to go see what's going to happen. So I created an init annotation, a before and after step, a cleanup, and a notify. So if we come back to Jenkins, I don't have to change anything because, again, those steps are, this can't be called notify. Notify. I bet it can be called that. All right, so now we can see what happened. So here's the original step, right, where we just called a build step. We had our init annotation get kicked off. We had our before step, the step itself, the after step, the notify, which happens after every step, the cleanup, and then notify again happens at the end of the pipeline. And there's actually a picture in the documentation that explains with a picture how these lifecycle hooks work, right? So the run starts, we're going to run validate, init for each step in the pipeline, before step, after step, and notify, and then clean up and notify. But there's going to be some use cases where I don't actually want to run after every step. So let's make this a little bit more sophisticated. These hooks can take, we call them conditional execution parameters. So we can define a closure here. And as long as this returns true, and we're going to get rid of the rest of this just to focus on these conditional executions. So config dot should notify. So let's say I wanted to make it a parameter whether or not to execute this notification. So I could save this. We could come back to Jenkins. In Slack, I can define that should notify equals true. So what you would expect is that there's going to be a build step and then the after step. But now I can tailor that. So I can say should notify equals false. And these lifecycle hooks are able to determine, based on the code that they're provided, whether or not they're applicable to the given environment. So that's really helpful for things like if you wanted to send like Splunk events or you wanted to do emails or Slack notifications, a way for you to do that without having to codify that into every single library. Another example real quick would be, you could also say an array. So like return true if the config dot, well, we can use both hook context and config. So let's say, just to show what I'm getting at here, inside my Slack library, if I wanted to say that here's the list of steps you should notify after deploy to, the way you would represent this logic would be return if the hook context dot step, which is the step that's pertaining to the hook that's corresponding to it, is in the config dot after steps, right? So these hooks they're pretty neat. You can do all kinds of stuff. There's also the current build variable in there if you want to alert only on failure. But lifecycle hooks are just one of my soft spots in the framework that I like to show whenever we talk about JT. So with that, I could go on for a while, but I see we're coming up on time. I want to make sure that we've got plenty of time for questions.
Yeah, there's a question out here. What's the best practice to share the libraries across all workflows and projects?
That's a great question. So open source is the default answer to everything. The second best answer is inner source. So I work at a federal consulting firm called Dsl and Hamilton, and we have libraries. JTE is the core of a larger thing called the Solutions Delivery Platform. Not super relevant right now, but to answer your question, like within Booz Allen, we have, we call them our SDP libraries. So we have a portfolio of libraries that get used across projects. Sometimes they get forked for like specific clients that need specific use cases. Ideally, those changes come back here. But this becomes building blocks across your organization to reuse pipeline code. And we have some standards around how these libraries can be changed. So if we go look at the documentation, so alongside the JTE docs, we've also got these pipeline libraries docs. Every library that we have actually has an ASCII doc file. So if we look at SonarQube, we use a framework called Entora, but this best practice applies to if you're using Gatsby or Sphinx or MakeDocs or whatever. So every single library is required to have a documentation page that outlines these are the steps that are available when you load the library. These are all of the configurations that library is going to take. And then, examples and any external dependencies, right? So for the SonarQube library, you need SonarQube. So that gets documented. So my recommendation would be that you have a repository within your organization. You set up a documentation framework so that everyone can see what are the steps available to me for use. And unit tests are good. So if you look at this, and I can paste the link to it, we use a framework called Jenkins Spec to write unit tests for, I'll say, most of these libraries. I won't promise that every library has tests, but it's in the backlog. So I hope that answers your question. The inner source and open source are the ways to go here with public-facing docs around the libraries and what people can build with them.
Steve, this has been an awesome presentation. Great job. I love that you did it all via demo. I learned so much about how this is set up. One last question here is, what is that Jenkins tool for UAT?
User acceptance testing? You mean, does the question referring to how do we make sure the libraries work as expected?
I don't know. Let me, Darren, you are allowed to talk. I just opened it up for you if you want to ask that question directly.
He just mentioned the tool a second ago.
Jenkins Spec was the tool. So inside the test directory, I'll show an example. Let's hope this is a good test. We have a penetration test spec. So if we open this up, so Jenkins Spec is a separate project from JTE within the Jenkins open source ecosystem. My Google Foo, Jenkins, Spec. I think it's from Expedia Group. So you can pull this in as a dependency and then getting into, and I'll paste this link inside the chat.
Awesome. Thank you very much.
Yeah.
So we were at the top of the hour. We certainly, it looks like there's another question. What was the documentation page you showed with the diagram?
That was right here, and I'll paste it in the chat.
So just for a follow-up for next month, the CDCon is, I'm going to go ahead and share my screen. So I'm going to take it from you, Steve. CDCon is the 22nd, actually through the 24th. I am going to go ahead and put this in the chat. If I can find the chat. I will put that in the chat in a moment here. So do register for it. It has, the schedule is going to be pretty interesting. We're going to have a, there will be a day zero, 2 day zero co-located events. One's a Spinnaker Summit, one's a GitOps Summit. And then we'll have the regular sessions the 23rd and the 24th. It is free to register, and we hope that you can attend. And most of these will be, I assume, will be posted on demand afterwards, as well as Steve's presentation he just did today. I will make sure that that is posted out to everyone who registered, and it will be uploaded to the CD Foundation's online meetup playlist on YouTube. And on that note, thank you, Steve, so much for your presentation. Super, super, really informative, and I think we'll get a lot of views off of this one.
Thanks, Tracy. Thanks for having me. Thanks,
everybody,
everyone, for joining.
Yes, everybody stay safe, and we'll see you in a month. Thank you.